find the mode, median, range, and to find the standard deviation, which is our new part. I'm gonna start with the listed number, which is here, 18, 22, 26, 39, 45, 46, 46, and then 52, 54, and I'm gonna go for 58, 62, 62, 62. It seems here that the mod is 62, 67, 70, 71, 75, 78, 82, 89, 91, 95, and 98 again. So here, if we will find the mod, we can check which number is the most repeated number, and it seems here that the 62 is the mod, so the mod will be 62. If I want to find the range, as what you know, the range is the biggest number, which is 98, minus the smallest number, which is 18, and in this case I'm gonna get it equal to 19 minus 89, which is equal to 80. So this is the range in this case. I'm gonna find also the mean. The mean, if I want to find it, I need to add all the numbers and divide it by the number of the numbers. And it seems here that the number of the numbers, I think it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So the number of the numbers is 23. I need to keep it here. I'm gonna use it later. What I want now to find, I need to add up all the numbers and divide it by this number. If I want to skip this step, I'm gonna use my graphing calculator, and I need to list all the numbers here. I need to enter all the numbers and then go till the end. Let's say I need to check here if we have calculation. Yes. So I'm going to make calculation. I need to check the set. The set, I need to see that the frequency, it's in the first row or in the first column. Because if it will be in the second column, this means we have two columns like this, table of values. I have, let's say here X, and I have here the frequency. So I have numbers here and here. So in this case, I have two columns. I need, according to this, if I have two columns, to change the second one and make it 2. So this is what I need to. This means the frequency, it will be in the second column. But because we have the frequency in the first column, so what I'm gonna do, I'm gonna put it in 1. So I'm gonna press only an F1 to get this. Okay. When you finish, make exit and go back to our table. And I need to start now finding the variable, the first variable. So I need to press this one. If I want to find the sum of all the terms, this means it's the sum of X here, sum of X. So I can say that the sum of the X, which is the total number here, equal to 1408. So this is what I want to get from the calculator. Again, I'm going to do it here, sum of X. And if I want to find the mean, I need to divide the sum by this 23. And if I'll do this, if I'll divide 1408 divided by 23, I'm gonna get the answer 61.2. And instead of doing all of this, dividing by n to find the mean, I can direct find the mean in the graphing calculator, which is X bar. X bar equal to 61.217, and it's direct now. I can find without doing this calculation. So it's X bar, and the sum of X, it's given for me here. The number of the terms, it's given also for me, it's a 23 in the calculator. If I'll go down, I can find here a mini. It's mean the smallest number in the set, which is 18. And if I'll go more, I'm gonna find the biggest number, it's 98. And you can check also here in the numbers, it's 98, the biggest number, and the smallest number is 18. If I want to find the range direct, I'm gonna take max minus mini, so I can find the answer direct. If I want to go for the mid, the normal way is just skip two numbers, one at the end and one at the beginning. Skip until I can find two numbers in the middle, which is given for me mid if we have even numbers, and if it's odd numbers, I'm gonna get only one number in the middle. And if you want to do this, you can cross it like this. I'm gonna cross 98 with this one. Cross again another number like this and like this and like this till the end until you will reach the middle of the values, let's say, and you're gonna get that the middle of the values in this case is 62. And if you want to check that we have mid 62, it's also given in the calculator 62. So we can find the mod, we can find the range, we can find the med, we can find the sum of the values and the mean, all from the calculator by entering all the values like this and find it in variable 1. Okay, I'm gonna go now for the new part of our lesson, which is talking about the standard deviation. The standard deviation, as what I said before, it's if I want to know the, let's say if I have the data and it's separated, and I want to find the relation between the data and the mean, I can use the sigma x. So I have many data, let's say, and I have mean in the mid. I need to know how far is the value from the mean. I can use the standard deviation for that. But if I have, let's say, if I plot all the points, I'm gonna find 2 points out or not close to the other points. I'm gonna name the 2 points, let's say, outliers of the data. Now, the standard deviation will help me to know how far is the values from the mean. If I can find the standard deviation, I need to use this rule, which is sigma x equal to 1 over n, the sum of all the numbers starting from 1 till the end of the number of the numbers. And here it's the number of the terms or values or numbers. And I'm going to make the sum of xi squared, which is the sum of all the numbers, all the values, minus the mean squared. So this rule will help me to find the standard deviation. Again, xi is the sum of values, and if I want to find x bar, it's the mean of the values. So if I want to find the standard deviation, I can use the calculator for that. I'm going to find it sigma x, which is equal to 22.143 to the second decimal place, it will become 22.14. So this is how we can find the standard deviation using the calculator. Now I'm going to go for another part of our lesson. If the question will ask me to find the variance, I'm going to take it every time the standard deviation to the power of 2. So this will help me to find the variance in an easy way. Variance. So the variance equal to sigma x to the power of 2. And we can also take it from the calculator, 22.14, and make it to the power of 2, 22.14, make it to the power of 2. Direct, I'm going to get that the variance equal to 490.179, and to the decimal place, it becomes 490.18. That's it. Now, if we want to find the range between the data, I'm going to say the biggest number minus the smallest number. But in this case, the range, it will not show me a really answer for how the data separate, because in some cases, we're going to get outliers which so far from the values of the data. So I need another method we can use it to find the relation between the data if we have such outliers, let's say, in the values. I'm going to use in this case the interquartile range, which is IQR. And in this case, it will show me how, let's say, the separate of the data in a reliable than the range, because it's not affected by the outliers. What I'm going to do now, if we have odd numbers of values, let's say 1, 2, 3, 4, 5, 6, 7, we have 7 terms, odd numbers of values. I know that the median will be the middle number, and it's clear for us here. Now, if I'll decide which one is the middle number between the first number and the middle number, we have, let's say, mid of values. Let's say one number before, one number after. So this is the mid of values. I'm going to name it lower quartile. So in this case, this is the lower quartile, which is 1/4 from the total of the data. And if I want to find the upper quartile, what I'm going to use also to find the IQR, I need to use one number before, one number after, and put it in the middle. I need number of values after and before the upper quartile should be the same if it's after the median. So in this case, I'm going to say that this is 3 out of 4 from the data. So if I'll find the upper quartile and the lower quartile and subtract them together, I'm going to get the interquartile range, which is the more accurate range if we have outliers data. And if I have even numbers of value, I know that the median will be in the middle of the values. I'm going to get 4 before and 4 after, and we have here 8 numbers of values, even number. So the median will be in the middle. So I need to decide or divide, let's say, the previous part, which is before the median, into an equal part, 2 before and 2 after. So the middle part will be our lower quartile. And the same thing, I'm going to do it for the after the median part. I'm going to put also the upper quartile here. And I'm going to say that the upper minus the lower, and I'm going to get the IQR. Now, I need to apply this one on this example, let's say, for the previous example. As what you can see here in the previous example, if I'll divide it, I'm going to get that the 62 is the median of the values. And if I want to divide all the terms, let's say, before and after, I'm going to get here terms before. I'm going to take the middle of the terms, which is 46, and we're going to get terms also after, and I'm going to take the middle of the values. So I'm going to get that the lower quartile in this case equal to 46, and the upper quartile in this case equal to 78. So here 78 and here 46. And if I want to find the IQR, which is interquartile range, in this case I'm going to say 78 minus 46, which is equal to 78 minus 46, which is equal to 32. So I can know that the range, the accurate range or interquartile range, equal to 32 in this case. Now, this will help me to get more accurate values if we have outliers. Another way to find the lower quartile and the upper quartile, if we have odd numbers, I'm going to say n plus 1 over 4. And in this case, this place will give me the lower quartile. This is if we have odd numbers of values. And if I want to find the upper quartile, what I'm going to say 3 multiplied by n plus 1 over 4. Like I'm saying 3 out of 4, which is 3 out of 4 of the number of values. This is if we have also odd numbers. This is easy to use. But if we have even number of values, I'm going to say direct n over 4. This will be the place of the term, which is the lower quartile, and n over or 3 over 3n over 4, it will be the place of the number which is the upper quartile. So remember, I'm dealing here with the places only. In which term is this? Okay, so I can apply it also in the previous exercise and say that n plus 1, if we have here number of values at 23, so I'm going to say 23 plus 1 over 4, which is 24 over 4. So in this case, the sixth term will be the lower quartile. And if we want to check in our values 1, 2, 3, 4, 5, 6, sixth term, it would be the lower quartile. And if I'll do the same thing, multiplying 3 by 23 plus 1 over 4, so I'm going to say 24 times, it will become the 18th one. So in this case, the 18th one, if I'll count here, I'm going to say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. And it's true here, it's the upper quartile. So this is another way to find our lower quartile place and the upper quartile place using the rule. You can memorize it here, n plus 1 over 4, and 3 multiplied by n plus 1 over 4. This is if we have odd number of values. And if I have even number of values direct, I'm going to say n over 4 and 3 over 4, and to get which place of the upper and lower quartile terms. So this will lead me to find the IQR in a direct way. Now, how can I use the calculator to get this? An easy way to use the calculator, I'm gonna start with this one. Okay. Yeah, it's here. So in this case, I can find Q1 of the values and Q3 of the values. It's given in the calculator, Q1 and Q3. Q1 will be the lower quartile, and Q3 will be the upper quartile. So what I'm gonna do here, if you can compare it also with the values, what do you have here? This is the lower quartile, which is 46, Q1, and the upper quartile, which is Q3, 78, and it's true here in our work. So direct, I can say that the IQR using the calculator, it's Q3 minus Q1, which is 78 minus 46. So I'm gonna get it equal after that to 32. So direct, we can use it from the calculator also. We can get all the information. What do you need to find the interquartile range? Thank you. Now I'm gonna apply what we learned about the interquartile range and how to find it, and the variance, how to find it also, and the normal range, how to find it on example number 3 in your book, part B. If we have the score given for us here and we have the frequency also in the second row, we need to enter it normally in the statistic part in the calculator, but we need to check if the frequency in the second column or not. So what I'm gonna change this number into 2. So I'm gonna change it by 2 and write 2. So in this case, I'm gonna change less 2 for the frequency, and I'm gonna go back and do my works. Now, one variable. If the question will ask me, let's say, to find, like what you have in your book in exercise, we have it in exercise example 6, they are asking me to find the variance to do decimal place. So I need the variance to 2 decimal places. This is part 1. And in part 2, we need to find the range. And in part 3, we need to find the interquartile range. This is what we need to find. As what we said before, that the variance is sigma x, but it's to the power of 2. So according to the information here, we have sigma x equal to 2.8. And if I want to find now the variance, I'm going to say sigma x to the power of 2 to get the variance. So using the calculator, 2.8 to the power of 2, it will become 7.84. So this is how to find the variance. It's wrong. So if I want to find the variance, as what we said before, I need to find sigma x and put it to the power of 2. It will become 2.8 to the power of 2, which is equal to 7.84. And if I'll continue, it's exactly 7.84 to do decimal places. This is what they asked me to find. And if I want to find the range, which is the second part, I'm going to say max minus many from the calculator also. So I'm going to search here for the max word. Max is 12 minus the many of the values, which is 2. So it will become 10 in this case. This is the range. And if I want to find the interquartile range, I'm going to compare between the interquartile range now and the range itself. The interquartile range, as what we said, I'm going to say it's Q3 minus Q1, also getting this from the calculator, which is 8 minus 3, which is equal to 5. And you can see that the interquartile range is more accurate than the range in this case. So this is how to get all the informations for example number 6 or question number 6 in your book. I'm going to keep as a homework with you exercise 3D. What I want from you, find the standard deviation and find the variance for that and find the range of the values. I want you completed from question number 1 till question number 7 as a homework and submit it on the Google class. Thank you. And before finishing this part, which is part 3.1 from your book, I need to compare between the standard deviation and the mean, and I need to show you what will happen if we will add or multiply numbers by all the numbers, what will happen to the standard deviation and the mean. If I will add one number, let's say I have list of values like what we did before in example number 3, I have list of values and I need to add for all the values one number, like let's say I need to add 3 for all the numbers. So in this case, the mean, it will be affected. So it will become x bar plus this number, which is k. And if I want to subtract, I'm going to get the same thing. The x bar, the mean, I'm going to subtract it by this number. So this what will happen if I'll add or subtract the same number for all the terms in the table. So it will affect the mean. I'm going to add the same number for the mean or subtract the same number for the mean. But in the standard deviation, it will stay the same. So, and this is the first case. In the second case, if I need to multiply one number, the same number k, let's say, by all the values in the table, so what will happen to the mean? In this case, I'm going to multiply this number by the mean direct and get the value, so it will not be affected. So if I multiply the table, the whole table, by a number, I can multiply the mean by this number, so I'm going to get the new mean. But if I have standard deviation, what I'm going to do, I'm going to take the absolute value of this number and multiply it by the standard deviation to get the new deviation. So I can't get it as a negative number, or I can't get it as another number. It should be positive to get the new deviation. So in this case, I can say we finished part 3.1 in your book. And I want you, as what I said before, I need from you to complete exercise 3, detailed question number 7. Thank you.